What we want to do today is, sort of um, share with you some more of the information that we've been able to put together through this data mining project, and it's related to lactation curves. Is certainly not just my work, and I've had the privilege of working with Dr. Dave Kelton, Dr. Ewan Ferguson, Karen Hand, and the four of us have worked on this over the last 6 or maybe it's 7 years now, but for sure 6. And our interest was to get into the vault. And you're going to say, well, what is the vault? Like, what do you mean by that? And the vault in our context, or the context for this whole project, is the data processing center and all the data for all the herds that are on milk recording across the country. And we've been looking through data, ever since we've started this journey, we'll say. And there's two distinct parts. One is, we wanted to provide detailed production and reproduction benchmarks. And we covered this off in December. So that was kind of part one, we'll call it. And then, the second piece to this project is, can we provide more insight on herd management? And at first, we weren't exactly sure how we were going to do this or what we could glean from this. We started small. We tried to put characteristics to what is a great repro herd, and we did some presentations around that. We talked, we looked at, some early lactation or quick culls, and are there differences across different milking systems and barn types? But as we present this kind of data, we're challenged by customers like yourselves to provide more information and to shed more light on questions that are much more complex. And that's what it's evolved into. And that's what's made it a lot of fun, to be honest. So in the last few years, especially the last 2 or 3, we've tried to dig in quite a bit actually into these general topics about peak and persistency. How does that impact herd performance? Is there any interaction with lactation length potentially? And how could it be what is the interaction and how do they relate? Talking about transition and digging into transition period and looking at traditional and maybe not as traditional type metrics, observations on herd demographics. And we've spent quite a bit of time on this for sure. Some interesting pieces that we've pulled out to describe that in some detail. Looking at age at first calving and how does that impact productivity, not only in the current lactation, but for future lactations on those animals. And we're going to share some new findings or some new insights or observations on some of these topics today. And specifically, we'll want to describe peak and persistency some more. This really forms the shape of the lactation curve, and just give some more observations into how does that tie into herd performance. And does this length of lactation, which might be guided by what we perceive our lactation curve to be, is there some influence on herd productivity? Before we dig into the information and some of the data that I can share, just some notes on the characteristics of the data, we'll call it. Today, all the information I'm going to present to you is totally observational. There's going to be no attempt made to try and tell you some kind of cause and effect relationship between different variables. The exercise that we've undertaken the last number of years, that isn't the point of it, and that we didn't carry it out in a way that we could find cause and effect. Okay. I think the goal has been to provide insights and observations on real life questions. We try to be practical and explain to people, what are we seeing in the industry? What are we seeing out there from a tremendously powerful data set? Okay. And the other point to note about the data that I show, a lot of the data that's going to be shown is going to be the 50th percentile. And for those of you maybe not totally familiar with percentiles really means ranking. So we take a variable, we rank it. The 50th percentile is the middle of that ranking. Okay. And you're going to have half the data points that are going to be above that number and half that are going to be below. So just keep that in mind that there's a distribution. And I have tried to add some slides and some information to help describe this distribution for you today. So a real life example. So here, here's a lactation curve for a herd. The command to generate it in Dairy Comp is there in the title. You can, other softwares can generate something similar, of course, but really the lactation curve is a picture of the peak and persistency and how they're combined to map out, hey, when's milk made during the lactation. I will offer that a lot of producers will not know the shape of their curve, but I think what they perceive the shape of this curve to be is going to guide them or inform them of making management decisions on their farm. Okay. And just as a point of reference, so this kind of curve here, and you can see the y-axis, the x-axis is the stage of lactation in the form of weeks. So the 2 on the left-hand side, that'd be 14 days in milk. The 48 on the right-hand side of the graph along the x-axis, that's going to be about 11 months, right? So, and everywhere so instead of days in milk along the axis, it's weeks in milk. And this is it's a high producing herd. This curve represents a real herd and it's high production herd. Okay. But just to give some context on persistency and peak, and I think there's lots of ideas on how that has trended over the years. So this is looking at lactation 1 animals in the best of the best herds. Okay. So it's the top 75%, it's the top 25% of the top half of herds in the West, lactation 1, going back all the way to 2005, up until this last year. And you can see, the orange bars represent peak and how, the peak levels over time, and the blue line represents persistency. And you'll notice both of them show a significant trend upwards over the year, which doesn't surprise us, I don't think. And if we look at this 20-year period, persistency level has increased by almost 8%. Okay. And that's significant, right? But if we look at the orange bars and how much has peak increased, you'll notice that for lactation 1 animals, peak has also increased almost the same amount. Not quite, but almost the same. Okay. So not only has persistency increased, but so has peaks. All right. And that's for lactation 1 animals. So now we look at our mature cows in the herd. And again, these are for Western herds. It just happened that that was the region we looked at this in some detail. I will offer to you that there's a very similar trend across all the regions in Canada. But if we look at the mature cows are lactation 3 plus out in the Western herds over the last 20 years, persistency has increased about 9%. And that's the blue line, the trending in the blue line going from 2005 to 24. Okay. And if we compare that with peaks, for our mature cows, peaks have increased even more over the last 20 years. And I know when we looked at this kind of stuff and tried to put some trends to it, and we did this, I think, the first time 3 years ago, I think we're a little surprised. A lot of people will tell us, yeah, my cows are way more persistent now, way more, and that's where all the milk's coming from. And so we would have expected persistency to maybe have increased over time a lot more, but that's not really the case. That's not what the data is telling us. Okay. So there really is a similar increase in both peak and persistency over the last 20 years is what we're seeing. Okay. So if we look at our benchmarks in 2024, and we covered a little bit of this last time, but if we look at, from herds that are not so good at making peak milk to herds that are great at doing it, there's about a 12 kilo spread. And as I mentioned in December, I always find this extremely interesting. So what are the herds doing that make 37.4 kilos of peak milk and compared to what the herds that are making 48.9 kilos of peak milk? What activities are different? What processes are different? And we don't know that exactly. Okay. So we just got the numbers here. We look at the difference between lactation 1 and lactation 3 plus. Obviously, our peaks would be higher for mature cows. That's no surprise. The reason I maybe raise this is if you look at the 90th percentile or the herds with the highest peaks, there's an even bigger spread between lactation 1 and 3 plus. And, I think those herds with really high peaks do a great job of getting lots of milk and early lactation from their older cows. And I think that's where a lot of it comes from, in my opinion. If we look at the timing of peak, right, and this is something that maybe we didn't really touch on last time, some interesting pieces here. Lactation 1 animals seem to peak about 3 weeks later than our older cows in the herd. Lactation 2 and lactation 3 plus, they peak around the same days in milk. Okay. And why we think this is interesting, and again, guiding, when do peaks happen? How high are peaks? How do those values potentially guide producers on making decisions related to voluntary wait period, related to feeding cows in early lactation, and the timing of making those decisions and taking action in those areas? I think these numbers maybe are a little different than maybe what we thought. And I know Dr. Ewan, Dr. Wayne Schufeld, who I worked with a couple winters ago a lot on this stuff, they were totally surprised on the timing of when peaks occur based on their years in practice. If we look at persistency benchmarks with some detail, so these are, Canadian numbers, regional numbers are very similar. We don't have time to go through every region, of course. Just as a point of reference, the way we're defining persistency for this talk today, and we have to do it this way because that's how it's defined in the data processing center. So we kind of have to go with this. But lactation persistency is the ratio of daily milk made at 280 days in milk divided by the milk made at 60 days in milk times 100 to get a percentage or to create the ratio, right? And this is lactation persistency. This isn't because sometimes, certainly with Lactanet data, Lactanet test day data, sometimes persistency is referred to what is current test day milk compared to previous test day milk. That is not what we're talking about here in this presentation today. We're talking more at a whole lactation level. And if we look at it, I think it's important to look at persistency by parity because there is a significant difference, especially when we talk about first lactation animals. They'd be in the mid to high 80s as a general rule. Our second lactation animals, low to mid 70s. And it also normally represents something similar to our herd persistency. And then our oldest cows in the herd, or our most mature cows, they're in the mid to high 60s. Okay. And you can see the range of data for the parities based on the percentiles, and you can have some tremendously high numbers and some tremendously low numbers too. But in the middle, or at the 50th percentile, that's what we'd expect. Okay. So if we go back to our real life example here, and here's our lactation curve that we mentioned earlier or shown earlier, right? It's a 12,800 kilo 305 milk herd. It's in the 90th percentile at that production level. Our peaks are around 52 kilos, right? And our persistency is milk at day 280, which is at week 40. And we're saying it's around 36.5 kilos. Our milk at day 60 in lactation is around 52. So our persistency is at 70%. Okay. So our peaks at the herd level are in the 90th percentile. Our persistency doesn't fare as well when we compare to industry benchmarks, right? So this herd isn't very persistent, but they peak very well. Okay. And if we want to dig into it in some more detail, when we start looking at it by parity, right? The command to generate a graph like this or some lactation curves like this is in the title. I think it's always important to look at both persistency and peak together. Sometimes cows are or herd can be very persistent, but it's because they're not peaking very well, right? So is that a positive thing, a negative thing? Maybe it doesn't matter type of thing. I'm not sure, but it lends itself to we want to look at both things together. Compare your herd to the benchmarks. That's what the point of the benchmarks, and it gives you sort of a way to understand a little bit more or a little bit better where does your herd sit, and is there something that needs to be done differently potentially. And I think certainly parity difference can offer up some different opportunities to focus on in terms of management as well. And if you look at the peaks and persistencies by parity in the brackets in that box in the bottom left corner, we can see how this herd fares, right? So peaks are tremendously high for our older cows in the herd. They're doing pretty well for first lactation, and then persistencies rank progressively lower as the lactation group gets higher. Okay. And if you want to tackle or dig into this kind of data more so with dairy comp, you can look at trends and that, and with a scatter graph on the left-hand side, and the command is there. I always recommend using \B. So you look at both cows that are still in the herd and cows that have left for the filter that you choose, right? So this on the left-hand side, all cows fresh in the last year have to be at least 50 days in milk. We use the same filter to generate the summary table on the right. We've got peak values and days in milk to peak values, and we got some numbers instead of just looking at a curve. And, those numbers on this table line up pretty well with the numbers that we saw on the graph in the previous slide. Okay. You may have to create a new item in dairy comp, and the dairy comp support team is more than happy to help you create this PKDIM, which tabulates days of milk at peak. If we want to talk about how does milking frequency, with the advent, or not the advent, but with the increase in technology on farm and the increase in robotic milking, I think, well, how does that impact productivity, milk production? We add in 3x herds as well. So if we look at the 50th percentile data for Canadian herds on the left, blue bars are 2x, orange bars are robotic, gray bars are 3x. You can see how peaks change. So they get progressively higher with increased milking frequency. And you can see the percentage increases in the blue box up top above the graph. And those numbers, those percentage increases probably shouldn't surprise us, because if we just look at overall milk production, those numbers sort of fall in line with what we would see just in general production. And it looks like in the 90th percentile, those increases are tamped down just slightly. Okay. But so kind of interesting looking at it at a regional perspective. I do this partly to make sure you're aware that we do have regional numbers for this. I'm not showing Ontario just because there's some wild and crazy unique thing about it. These patterns are similar across regions. They truly are. These are numbers for Ontario herds, and they line up closely with what we would see in Canada, which again shouldn't surprise us a lot. Okay. But as we increase milking frequency, our peaks are increasing. What is a little more interesting to talk about, and maybe isn't always as obvious, or I guess obvious, maybe, I don't know, is persistency, and how does milking frequency change that? And again, these graphs are laid out the same. 2x herds are blue, robotic herds are orange, and 3x herds are in gray. On the left-hand side is the 50th percentile. So this would be middle type herds. And you can see that certainly for 2-year-olds, the more times an animal's milked, meaning 3x being most times, and robotics, they'll be, similar to that, I guess, but not quite 3x for everybody. There's an increase in persistency. But then when we look at lactation 2 and 3 plus, we're seeing that the AMS, or the robotic milking herds, their persistency goes down, not a huge amount, but it does go down a little bit. And it would be the similar type of pattern for the 90th percentile. It's just the magnitude of the numbers in the 90th percentile are bigger because they're the top numbers, right? But the pattern is similar. And again, we look at it for Ontario, and we've got similar type of patterns at a regional level. Okay. And, we could do the same thing for Quebec or for West or for Atlantic. We just don't have the time to show all the graphs. Want you to be aware there is a regional component. And if you would like to see your own region, don't hesitate to reach out, and I can provide that if you want to see that. So one of the comments that I've heard over my time here at Lactanet and working with data, working with Dairy Comp too, of course, is, if we're going to strive for really high peaks, well, that must mean we're going to have to sacrifice something. And one of the things, well, we're going to sacrifice on repro because the cows are just working so hard in early lactation, they can't get pregnant. Okay. I don't know if I would say that for sure as a common perception, but maybe. Is there a common outcome to this? Maybe. I do think it is somewhat herd specific because it does come down to management at the end, right? But how does peak milk interact with insemination rate or conception rate or pregnancy rate? And we have some data that we can share with you about it. So this data here is taken from all the all the herds that are tested by Lactanet, and the DPT, or the field technicians, are using Dairy Comp. So that would mean Ontario and the Western provinces. And these metrics are easily available for all these herds. And this is the method we have to follow to get the data. And we just unfortunately don't have that going in the eastern part of the country. So Western herds are blue, Ontario herds are red, and you can see how. And then along the x-axis is the bands of peak milk. So the herds with the lowest peak milk levels are on the left. The herds with the highest peak levels are on the right. We have 50th percentile numbers on the left-hand side, the left-hand side graph, and 90th percentile numbers on the right-hand side graph. And you can see in the 50th percentile, especially in Ontario, there's a steady increase in pregnancy rate when we look at herds going from low peaks to high peaks. Okay. I would say out west, once we pass the first peak milk band, so the three highest peak milk bands, there it's not as obvious a trend, but there is a subtle increase higher for preg rate. And if we look at the 90th percentile, it would follow a similar type of trend. Ontario, there seems to be more of a difference from low peaks to high peak herds in terms of pregnancy rate. Out west, if we remove that first peak milk band, then our pregnancy rates seem to be similar. If we look at insemination rate, again, this follows a similar pattern as it does for pregnancy rate on the previous slide. Ontario, there's a very obvious trend in the 50th percentile graph on the left. The red bars get increasingly bigger as we go from lower peaks on the left to higher peaks on the right. The Western herds, if we leave out the first band of peak milk herds, then it's fairly consistent. A little bit of an increase in those top peak milk herds. The 90th percentile, it follows a similar type of pattern. Just the magnitude of the numbers are bigger. Okay. Conception rate is a little bit of a different pattern in that on the left-hand side, and when we look at the 50th percentile of conception rate across those different peak milk bands, it doesn't matter what type of peak milk herd you are, it appears that that conception rates are the same. And it doesn't matter if you're out west or in Ontario. When we look on the right-hand side graph in the 90th percentile, it is sort of a similar type of scenario, except for that very low peak milk band. And that's increased by 5 to 7 points of conception rate. And you're wondering, well, why is it bucking the trend here? Because that kind of goes against all the other slides so far. And I'm going to offer that I think this is related to breed, right? So think of Jersey herds. They'll all be in that bottom left, or sorry, in the less than 37.4 peak milk band. And there's some tremendously good repro herds, Jersey herds, and I think that's what drives this in the 90th percentile. Okay. So when we look at conception rate by parity now, so the parity is the different colors. So first lactation is blue, second lactation is red, third lactation is green. The same pattern when you compare across parities is the same regardless of peak band, peak milk band. And the interesting part is the conception rates are the exact same for all parities in all peak milk bands. Okay. I think we would certainly expect that regardless of peak milk band, our first lactation animals would have the highest conception rate. Our second lactation would be mid-range, and then our most mature cows would be the lowest. That would be typically what we would see, and it bears that out here. But the peak milk doesn't impact the magnitude of the numbers, right? So it appears there's not a lot of difference there. The one difference that you think you might see would be at first service conception. And, if there is an impact of peak milk level, it would be on first service conception rates. And again, what you're seeing here, whether we're out west or in Ontario, there's very little difference in first service conception rate across the different peak milk band levels. Okay. And if we look at the right-hand side, so the 50th percentile group is on the left, the 90th percentile herds are on the right. And again, same, just like with overall conception rate, that low peak milk band sticks out. And again, I'm thinking it's related to breed. That's my hypothesis. We haven't tested that. We didn't go digging, but I am fairly confident it's these really good repro Jersey herds that are driving this part up. Because we're we're looking at the top 10% of herds in this less than 37.4 peak milk band level. Okay. Some people might get a little excited because our pregnancy rate and insemination rate graphs that I showed earlier were created using a voluntary wait period of 50 days. There's going to be a number of people on this call probably, well, either my herd doesn't start breeding cows after 50 days of milk, we wait longer than that, or my clients wait longer than that. Well, then let's look at how well can we make pregnancies by a certain days in milk cut point. And the days in milk cut points are the colored bars on each graph. So pregnancies by 120 days in milk, by 130 days in milk, by 150 days in milk are the blue, red, and green bars respectively. And at the 50th percentile level for Ontario herds in 2024, there was a steady increase in percent of herd pregnant by those cut points. If we go to the 90th percentile on the right, there's a moderating effect there's not an obvious and steady increase as we go from low peaks to high peaks in this case, right? It kind of levels itself out once we get past 41.8 kilos of peak milk. Those last two bands are relatively the same. Okay. But at the average point or at the 50th percentile point, as peaks go higher, for herds with higher peaks, they also create more pregnancies by those different days of milk cut points. So, I think our data has shown, not just this year, but in previous years, that maybe the shape of the lactation curve hasn't changed overly much, but it's just that the whole curve has been raised. Okay. But I do think the perceptions still remain. Curves are flat. The lactation curves are flatter. Cows are more persistent. We capture more milk at the end of the lactation. We have big problems drying cows off when they're milking 35 or 40 kilos of milk, right? And that's kind of a separate issue. And there are relatively easy ways to deal with that, I think. But, I think having some of these perceptions have lend themselves to having these tendencies to maybe delay the voluntary weight and breed later and more often, which is then going to result in increased lactation lengths. And we might get more milk at the end of the lactation. It might be easier to dry cows off, maybe, but do we truly make more milk? Is it better for us to do those things because of this perception of, a different lactation curve shape? And, I'm not here to say one way is better than another, or this is the right way and this is the wrong way. I just want to show you what we're seeing with the data, because this can be a bit of a contentious issue, to be quite honest. But are there downstream issues? If we extend lactations because of these different things, what happens in the next lactation if we do that, as it relates to production, as it relates to repro? Are there consequences about, shorter dry periods, about body score in the next issue, which will then lead potentially to transition issues, which aren't a good thing either, right? So all of this stuff to me is intertwined, right? There's no right or wrong answer, and I don't think you can paint every herd with the same brush, right? So it's going to be very herd dependent. But when we look at herds and what is their average lactation length, and what is the distribution of that, when we only include completed lactations that ended after 305 days. And this is the route we took the last few years. So all lactations finishing after 305 days of milk, what is average herd lactation length? And the middle, or the 50th percentile, is 371 days in milk. And you'll notice that the 50% of the herds will have an average lactation length between 358 and 388. Okay. That's for 2024. If we look at the trend over time, so this is the last 3 years when we've really been digging into this more, the trend is very similar. And we're looking at it by percentile, right? If we look at the 50th percentile, for 2024, it was 371. And for 2022 and 2023, it was around the same, right? And the distribution of the data for all 3 years is almost identical, okay? And when we look at the trend, again, when we look at 305 milk, herd average milk by lactation length band, so now we're ranking all the herds by their herd average lactation length, and we put them into 4 buckets depending on where they fell. And you can see the buckets on the x-axis. And you can see the herd average 305 milk for those herds in those 4 different buckets. And the shortest lactations to the longest lactations, there was about 1,300 kilos of milk difference, at least in 2024. And it's very similar for the other 2 years. And if we look at 305 fats, it's about, for 2024 at least, it was about 55 kilos different from the herds with the shortest lactation length to the herds with the longest. And again, the pattern or the shape of this trend line is the same for 2023 and 2022. Okay. So this isn't a fluke this year. This is something that we've seen similarly for the last 3 years. So now if we just look at 2024 data, and I apologize for anyone that's here, that's on the call from the East, there's something that went a little sideways with the data for the Eastern provinces. And I didn't notice it in time to really jump on it to fix it for today. But it's very similar to, for sure, it's similar to Ontario and Quebec. But you'll notice there's a downward trend for all regions. Quebec region, maybe it's a little bit more tamped down, or the trend, the downward or the decrease in production from the shortest length lactation lengths to the longest is maybe a little bit more moderate compared to Ontario and even the West. Lactation 1 animals are on the right, left-hand side here, lactation 3 plus on the right. But it's a similar type of trend. If anything, it's more moderate for lactation 1 animals by the looks of it. So if we want to look at a lactation curve for the herds in these different lactation length buckets, we've done that here for the 50th percentile on the left and the 90th percentile on the right. And we have a similar shaped lactation curve. Okay. So it doesn't matter what the herd average lactation length is, the curve is similar in shape, it's just shifted up. And if you compare the 50th percentile numbers with the 90th percentile numbers, again, the shape is very similar, if not the same. It's just the whole curve for the 90th percentile has moved up. So you can see the peak milks on the 50th percentile side is about 45 kilos or thereabouts. And on the 90th percentile side, it's around the 50th, it's around 50 kilos. So the whole curve is shifted up. And I certainly want to acknowledge that Dr. Ewan Ferguson was gracious enough to share this slide with me to just give you another perspective on lactation curves. When is the milk made? So for herds that have, for herds that are in the less than 358 average lactation length band, this would be the lactation curve for that group. And it's the 50th percentile curve. And for a herd like that, or herds like that in that category, 61% of the milk is made in the first 200 days and 39% of the milk is made in the second 200 days or after day 200. The total area under the curve is 12,350 kilos. Okay. So just an interesting perspective on when is the milk made. Okay. And then we can look at 305 milk. And again, these are the buckets of herds. They're grouped by what their average lactation length is. So herds with the shortest lactations are on the left-hand side of each graph, and the herds with the longest lactation length, the longest lactation length is on the right-hand side of each graph. And then it's by percentile, just so you can see the range of the data. The green line on both sides is the 50th percentile. Lactation 1s are on the left and lactation 3 plus on the right. Okay. But there's for lactation 1 animals, so lactation 1 on the left. So, the one thing I will also say about these two graphs is whether you're in lactation 1 or 3 plus, it's a similar type of trend. So the shorter lactation lengths would appear they tend to have more milk, 305 milk, than the counterparts with the longer lactations. And it'd be a similar type pattern for 305 fats. And it doesn't matter what percentile you're in, whether it's lactation 1's on the left, lactation 3 plus is on the right. Okay. I presented the data this way so you could see the distribution of the data in each of the lactation length groupings or categories. And if you want to look at peak milks by parity for each of the lactation lengths, so on the left-hand side is the 50th percentile group or the 50th percentile numbers. So lactation 1 is blue, lactation 2 is orange, and lactation 3 plus is gray. But the highest peak milks in the 50th percentile are with the herds with the shorter lactation lengths, and the peaks get progressively lower as we move over to the herds with the longest lactations. And the 90th percentile obviously would have a similar type of pattern. The numbers are just higher. The magnitude of the numbers in each lactation length category are higher. And we maybe could say the difference between the short lactation herds and the long lactation herds is there might be less of a difference when we're at the 90th percentile. And if we look at persistency, it gives us a bit of a different story. So the 50th percentile number, so this is in the middle, is on the left. Blue is lactation 1, orange is lactation 2, gray is lactation 3 plus. These are all the herds in Canada put together here. And you'll notice that persistency, regardless of lactation group, is the same, regardless of lactation length. And that pattern holds when we look at the 90th percentile numbers for all parities. Okay. So the lactation length doesn't seem to interact really with persistency on these for herds, regardless of the lactation length bucket they're in. As it relates to repro, so for herds with short lactation lengths or shorter on the left-hand side, insemination rate is higher. The herds with longer lactation lengths, they have a lower insemination rate. Doesn't matter if you're in the West or in Ontario. And that doesn't surprise us at all. Conception rates, the pattern is sort of the same, but it's not as dramatic, right? So the Western herds are blue, the Ontario herds are orange. So for conception rate, we're around 45 and it dips to just below 40. So there's a 5-point spread going from shorter length lactations for herds with shorter lactation lengths to herds with longer lactation lengths. The one thing that we noticed and we dug into a little bit more this year is saying, well, maybe we should revisit this because how do we know when do all the lactations finish? Because the last few years, we just looked at lactations that finished past 305. And we were a little bit surprised by this. Almost 35% of the lactations end before 305 days in milk. I thought that was we all thought that was a significantly high number. It kind of took us a bit by surprise. So is that going to make an impact on the data that I've just showed you if we include some of these shorter lactations in the analysis or in the data mining? Okay, and you can see the color coding of the bars is the parities. Okay. And if we include lactations that ended after 280 days, so that adds another almost 25% of the completed lactations. Now 50% of the herds will have a lactation length average between 322 and 363. So it decreases the cut points by about a month compared to what I just showed you. But then when we look at, for lactation 1 on the left, lactation 3+ on the right, how does this revamped grouping of lactation lengths for herds, does it impact the trends for 305 milk? And it's by, the West, Ontario, and Quebec. And the one thing I will say it does do is it kind of moderates the impact as we go from the shorter lactation herds on the left to the longer lactation herds on the right, both for lactation 1 and 3+. The trend doesn't have as big a slope downwards as we go to the longer lactation herds. This is a similar type graph that I showed earlier, where we show you the distribution of the 305 milk data for the herds in each of these lactation length bands. Lactation 1s are on the left, and lactation 3+ on the right. Okay. And again, it doesn't matter really what level of production within any of these bands are. The pattern of the curve is the same or similar, with the biggest sort of variability in the curve from short lactations to long would be in that 10th percentile group, or that bottom blue curve. It seems to be a little bit more wild than the other 4. And then finally, the last point I want to touch on, and I struggled to put this slide together, to be very honest. My point is there a way to apply some of this data that I just showed you to within a herd? And the more I've looked at this and the more I think about it, I think it's going to be very difficult. And maybe I'm misreading. And if someone has a strong opinion on this, please send it my way. I'm happy to listen and happy to hear you out on it. But if we want to look at our herd or your client's herd, how can we compare lactation lengths with production? Because you can't really do it within the current lactation because there's a bunch of lactations not finished yet. So then you got to look at, well, what happened last lactation? Because that lactation is completed. And how do we do this in dairy comp? So there is an item you can create I call it P305M, and that's the previous lactation 305 milk. And I've broken down this herd's previous lactation days and milk lengths into quartiles, right? Similar to what we did with the data I presented for herds across the country. But this is one herd. And, some of the difficulties with looking at the data like this is you can't summarize across parities. Dairy Comp 305M, you can't look at previous lactation 305ME, which is really what you'd want to see. This is 305M. So then it becomes difficult to compare all the animals because they're all in different lactation numbers. The other issue, and then similarly with week 4 milk or peak milk, or, you're including all the lactations, lactation 2 and greater in here. You can't, you're not comparing apples to apples now when you bunch that all together. And the other issue that we have with this is that bottom quartile where it says PDIM and there's 407. So that's the average lactation length of the longest quartile in this herd. But guess which animals are kept the longest? It's the rock star producers, because you're going to keep trying to breed them back because you want them to stay. So that bottom row is going to obviously be biased and will always have a high production number there. So I struggle how do we use this? But I know there's a whole bunch of smart people on this call today, and they might generate something like this. And I'm raising it not to say this is an awesome way of looking at your herd data. I'm offering this up to you to say, be careful on how you interpret. That's the gist of why I'm presenting it. But I will say, just because it can be done doesn't mean it should be. So just be aware of when you're using the data to look at some of these things. I'm not always, I've talked a lot at the herd level today. Can we narrow it down to a single herd level and try to make some sense of some things? I'm not sure how easy it would be to do some of that.
Can the same curve be generated for kgs of fat and protein totals?
Yeah, it's a great question. It has come up before. My understanding with how the lactation curve type data is stored in the processing center, I don't think we can. But because I've been asked this several times now in the last month or two, that will be a project for me to determine. So my understanding is no, but I'm going to say that's not a hard no because I'm not 100% sure.
Fair enough. The next one I don't think is a question, more of a relief statement maybe, and others might feel the same way. I'm honestly a bit relieved to hear and see that the lactation length data presented. We're definitely seeing this here. The milk totals are good, or equivalent to longer lactations. I was worried we were doing something wrong. Um, I think I appreciated that comment. That's why I wanted to make sure I shared it.
Yes, thank you.
Another question here, Jeremy, is should I say it will be better to extend the voluntary waiting period of the the second and third lactation cows?
Hmm. I always find comments and suggestions or comments around voluntary weight period, I find are a little tough. I think one of the big things about voluntary weight period to consider is, you know, what kind of job are you doing with first service conception? Because if that is really poor, I think it's going to be difficult to suggest, well, we can delay a bunch our voluntary weight period. Um, what I have seen a number of herds do is they might delay their first lactation animals some and manage them a little bit differently than their older cows. They're more persistent. They potentially need more time to grow into their body and those kinds of things. Um, I don't know if I would say my data supports, yeah, let's just wait to breed cows, older cows. I guess there would need to be some more details about a certain herd or the scenario to say that. I'm not sure if I'm in a position to say, yeah, we should be delaying just based on the data I've shared. It's related to a bunch of other things. So,
Good. Another question here, Jeremy. How does lifetime milk correlate to lactation length?
lifetime milk is just going to be, what's the total production of that? What is the total milk that's been produced by that cow from the time she freshened for the first time till she leaves the herd? And, I guess if she does that in one extremely long lactation, which is very extreme, or she does it in three or four or five or six shorter ones, you know, that that's going to be her lifetime milk. Um, I think to produce milk efficiently, it's going to be dependent on, how persistent the cow is and some of those kinds of things to me. The problem that I see or that I have with lifetime milk when it comes to how are we going to manage our farm is it's not time bound. So it's great to say, hey, I've got 138,000 kilo milk cow in her lifetime, but did she make that in 3 lactations or did she make it in 15? And I think you would view those two cows differently if you knew what the answer was to that. So, you know, I'm not sure if lifetime milk, it'll be related to lactation length, but it's also going to be related to peaks and persistency and how well are those cows managed too. I think all of that is intertwined. I don't think you can just correlate one just lactation length with lifetime milk.
Okay, and another question here, Jeremy. Do you have any observations on quick call rates based on lactation lengths? One of the biggest problems I see on good farms with extended lactations is high BCS at end of lactation and transition problems.
That will be covered next session. Um, did we look at lactation? How does lactation length in the previous lactation impact quick call rate in the current one? My sense is we did not do that this time, but it could be done. But I don't think I'd have to go back in my spreadsheets to remember. And I can't remember if Karen put that together or not. But we're covering quick calls in the next session. So
Good. Yeah, there you go. Another reason to join in next time. So I,
exactly.
I believe, oh, sorry, we got another quick one here. Rephrase my question. Correlation between lactation length and days of life to 60,000 kg. So that's
That
the,
I
sorry.
that I wouldn't have data on. Um, um, you know, so how many lactations does it take to get to 60,000, or what is the optimal number of lactations to get to 60,000 is maybe another way of rephrasing the question. And I wouldn't have data on that part. But, you know, just I think of it, when the cow is standing in a stall, is she paying her way, and is she making good use of the real estate in your free stall or in your tie stall? And to manage based on lactation length, I think it's more, if that cow is making tons of milk and she's making efficient use of that stall space, then keep doing that. But if there's a better alternative to using that stall, then maybe we got to replace that animal and put somebody else in there. Or so that's a little bit more how I would look at it.
Good. We got another question came in, Jeremy. Is it fair to say that the lactation lengths may be more a function of repro results than a choice for longer lactations? Is it fair also to assume that DPD favors shorter lactation length as well?
Certainly, longer lactations is going to be a function of repro. I agree with that for sure. Is that the only reason why the lactations are longer? I would say no. I do believe there are herds where they're delaying their breeding, whether they choose to, whether they don't have a good system in place to make sure everybody gets bred at a certain days of milk or whatever. Um, you know, I think not, compromised repro will be one issue, but I think there is also a management component related to making choices to getting cows bred and those kinds of things too that'll influence that. Um, dollars per day of life and so on. That could be. It's not a metric that I use a lot. Certainly, we haven't looked at it in terms of our benchmarking and did a deep dive on stuff like that as it relates to lactation length. So I don't think I'm really, at least today, in a good position to answer that very well. So, but yeah, those are kind of my comments to that.
Okay, well, with that, Jeremy, thanks. Awesome job. I think it makes people look at things differently, obviously, by their questions, which is the whole idea of doing this. So with that, I want to thank everybody for being here.